November 1944. A Polish Home Army fighter crouches in the rubble of a Warsaw street during the final weeks of the uprising, holding a single-barreled shotgun with 2 rounds remaining. Standard buckshot ammunition has been exhausted for 11 days. The rounds in the weapon are not standard. Each has been hand-loaded in a basement workshop using salvaged brass casings, improvised propellant charges, and projectile material, nail fragments, glass shards, pre-war Polish 5-groszy coins. The fighter engages a German soldier at approximately 8 meters. The round discharges, spreading its irregular contents across a cone about 1 meter wide at that distance. Nail fragments penetrate clothing and skin. Glass shards cause lacerations across the exposed face and hands. 2 coin fragments, traveling at roughly 240 meters per second, strike the soldier's chest. The combined wound pattern is catastrophic at close range, not because any single component is lethal in isolation, but because the spread of irregular projectiles makes partial avoidance geometrically impossible at close distance. The German soldier falls. The Polish fighter advances, takes the man's ammunition, and continues. The improvised shell cost nothing. The materials came from rubble. The knowledge required to load it was passed between fighters in whispered instructions during the 9 weeks of the Warsaw Uprising's final phase, when conventional ammunition was simply no longer available. Resistance fighters and irregular forces across occupied Europe faced an ammunition problem that was logistical and existential. Conventional supply chains required capture or Allied parachute drops. Both were unreliable, intermittent, and insufficient. Standard shotgun ammunition, initially available through civilian stocks, was consumed rapidly once fighting began. Shotguns themselves were easy to obtain from farms and estates. Ammunition was not. What was needed was a method to reload expended brass casings using locally sourced propellant and universally available projectile material. Improvised shell loading emerged independently across multiple territories. The fundamentals were simple: a casing, a primer, a propellant, and a projectile. Primers were scarce and difficult to improvise. Propellant was the next challenge. Black powder could be manufactured from charcoal, sulfur, and potassium nitrate. Smokeless powder was more effective but chemically complex. Most improvised shells used black powder, less efficient but functional. Projectile selection departed most from commercial practice. Commercial loads used precise spherical lead shot. Improvised loads used whatever dense material was available. Nails, cut to 10 or 20 millimeters, tumbled unpredictably but retained energy at close range. Glass fragments caused severe lacerations, though penetration was limited. Metal coins, dense and irregular, delivered substantial kinetic energy. Lead pipe fragments, ball bearings, small stones, bolt heads, broken machine parts, all appeared in documented loads. The loading process required minimal equipment. Empty brass casings were cleaned and inspected. A measured charge of black powder filled roughly 1/3 of the case. A card wad, cut from cardboard, was pressed over the powder. Projectile mixture was poured in until the casing was about 2/3 full. A second card was pressed into place, the mouth crimped with a homemade tool or folded manually. The finished round looked crude, but chambered and fired reliably if the powder was dry and the crimp is secure. Operational use by the Polish Home Army in Warsaw is the most documented. Survivor testimonies describe improvised rounds used extensively in the uprising's final weeks. They were most effective under 10 meters, where spread could not be avoided and velocity remained sufficient. Beyond 15 meters, effectiveness dropped sharply. Projectiles destabilized, velocity decreased, trajectories became unpredictable. German soldiers who survived such wounds reported unusual injury patterns that initially confused medical staff. Comparison with conventional ammunition reveals clear differences. Commercial 12-gauge buckshot delivered around 2,800 joules of total energy. Improvised black powder loads delivered perhaps 1,200 to 1,800 joules. Less efficient, less predictable, but multiple wound types simultaneously created disproportionate impact. Medical treatment for combined nail, glass, and coin wounds was more complex than standard buckshot. Similar improvisation occurred elsewhere. Philippine guerrillas loaded bamboo shotguns with nails and scrap. French Maquis used salvaged hardware. Italian partisans documented comparable practices. The pattern emerged independently wherever ammunition vanished. The dangers were real. Black powder produced heavy smoke, revealing position. Improper loads could lodge material in barrels. Inconsistent powder measurement caused overpressure. Workshops lit by candlelight under bombardment could not ensure quality control. Some improvised rounds detonated during loading. Casualties occurred in basements before the rounds were ever fired. The fighters understood this and continued, because the alternative was fighting with nothing. The Polish fighter in November 1944 was fighting in the final days of an uprising that had already failed strategically. The Warsaw Uprising began August 1, 1944, ended October 2 with formal surrender. Some fighters continued resistance afterward, using whatever remained. The improvised shells changed no strategic outcome. They saved no city. They reversed no political decision. What they represent is the endpoint of ammunition logistics, the moment when everything supplied has been consumed and a force must choose between improvisation and surrender. The Warsaw fighters chose improvisation until there was nothing left to improvise with.